Good morning. This recording is for Algebra 1, Chapter 5, Lesson 3, Standard Form. But first, a quote from Horseradish, Bitter Trees You Can't Avoid by Lemony Snicket, page 119. I am sure you know the key to good eavesdropping is not getting caught. All right. Standard form is a linear equation, and it's the form ax plus by equals c, not to be confused with y equals mx plus b, but the y and the x and y equals mx plus b are very similar to the y and the x in standard form. Standard form is really cool because you can use it to graph y and x intercepts. You don't have to worry about slope. You basically just put two dots, one on the x-intercept, one on the y-intercept, and then connect the dots, and lo and behold, you have a line. All right? So when you plot the intercepts, you make x 0 to find the y-intercept, and you make y 0 to find the x-intercept. So we're going to go ahead and do a quick problem, and we're going to find the y and x-intercept for 4x minus 9y equals negative 12. So the first thing we're going to do is we're going to find the x-intercept, and we're finding the x-intercept, we make y 0. So we end up plugging, we replace y with 0, and then we solve for x. So we have 4x minus 9 times 0 equals negative 12. So we're going to keep solving. 9 times 0 is 0. We have 4x minus 0 is negative 12. You can just drop the 0. We end up with 4x equals negative 12. Divide by 4 on both sides, and we're going to get x equals negative 3. Basically, we're going to then plug that into here and make it negative 3, 0, and plot that point. I'll plot it in a second. Let's go ahead and find the y-intercept before I plot both of them. The y-intercept means that x is 0. So 4 times 0 is 0. 0 minus 9y is negative 9y equals negative 12. Divide by negative 9. You're going to get y equals 4/3 or 1 1/3, which means it's then going to get plugged into... give me a second. I'm having trouble with my... highlighter. Anyway, all right, you're going to plug it into that. Sorry. And then you're going to end up with the point 0, 1, and 1/3. You're going to plot the 2 points. There's the x-intercept, negative 3, 0, and there's the y-intercept, 0 and 1 and 1/3. And then you're going to connect the dots, and you have yourself a line. Pretty easy, right? Yeah, not that bad. It's almost easier, in my opinion, than the y equals mx plus b format, but sometimes your equations don't always come out in y equals mx plus b, in slope form, standard form. So yeah, sometimes you got to convert if you really want to go that far. All right, so in standard form, either a or b can be 0, but not both. If a or b is 0, the line is either horizontal or vertical, which is going to give us a hint on how to write either y equals or x equals situations in slope or in standard form. So just remember that when it's a horizontal line, the slope is 0. When it's a vertical line, the slope is undefined. So let's go ahead and write the equation. I've already written the first one out for you. It says write in standard form then graph y equals 5. So if y equals 5, x can be anything. X can be negative 100, it can be 2, it can be 5. It doesn't matter, because basically what the standard form tells us is that when y equals 5, x can be anything. Therefore, it doesn't matter what x is. That's why we're basically multiplying it by 0. So that's why this happens. All right, that's why that happens. So if I were to go ahead and graph this, x could be 0, x could be negative 5. Yeah, negative 5, x could be, I think that's positive 5. And then basically, it doesn't matter what x is, because we're going to multiply it by 0. It's going to cancel out, and then whatever we're left with, basically if we cancel that out, it's 1y equals 5. Well, y has to be 5 in this situation. So basically we're saying it doesn't matter what x is. According to this equation, y will always be 5. So that's how we end up graphing that as a straight line right there. Okay. So back here in the blue, don't have the arrow. Back here in the blue, we have write in standard form, then graph x equals negative 4. In this case, it doesn't matter what y is. x will always be negative 4. So basically that's where this whole 0 y thing comes into play. This is, it doesn't matter what y is. Y could be 4 billion, y could be 2, y could be 1. But x is always going to end up being negative 4 because this is going to basically cancel out, giving me this scenario, which means x always has to be negative 4, which I'm going to regret writing because I've got some other things in there. So there we go. So we've got negative 4, 0 is right here. We've got negative 4, 2, negative 4, negative 2. And again, it doesn't matter what y is because x is what's being determined when x is negative 4. And when it's just, writing it in standard form. So make sure you memorize this formula. When it's a y equals, y gets the 1. When it's x equals gets the 1, and the other one just gets the 0. Okay. Oh, and then whatever the x or y is what the final answer is there. Okay. Let's move on. All right, so when changing slope-intercept form to standard form, we're basically going from y equals mx plus b to ax plus by equals c. If an equation contains a fraction decimal, multiply the whole equation, then so that you can write it as an integer, as integers. Basically, we're clearing the fractions and clearing the decimals. You should be familiar with this. It's totally easy, but I'm going to show you 2 quick example problems where we're clearing the fraction or clearing the decimal. So number 1 has fraction in it, so we're going to clear the fraction by multiplying by the denominator, and the whole thing gets multiplied by the denominator. The y gets multiplied by the 5, the negative 2/5 x gets multiplied by 5, and the 1 gets multiplied by 5. So here we have 5y equals 5 over 1 times negative 2 over 5x plus 5 times 1. We're going to simplify before we multiply. The 5y just stays 5y. We're going to end up with a negative 2x plus 5. Now we just need to move over the negative 2x. By doing that, we're going to add 2x on both sides, which is going to give us 2x plus 5y equals 5. Hey, guess what? That is totally in the formula of, that's too big, of ax plus by equals c, where 2 is a, 5 is b, and c is 5. There you go. All right, the decimal form, we're going to multiply everything, and this is a 10, by the way. My cutting thing got a little off. So we're multiplying the whole thing by 10. And you really don't have to show all this work. You just need to know that, everything gets multiplied by 10, which is the equivalent of moving a decimal place 1 place to the right. So we're going to end up with 10y equals negative 4x plus 1. Because again, basically the decimals just, get moved over 1. Okay, so now I got to get this into ax plus by equals c. So I'm going to add 4x on both sides, and I'm going to end up with 4x plus 10y equals 1, and that is definitely in standard form. All right, last slide, which I kind of already showed you everything, but just kind of go with it for a second while I talk about this. So you're going to write an equation for the data. Man, did not spell check. Write an equation, this is actually supposed to be in standard form, to find the number of minutes someone who weighs 150 pounds would need to bowl and walk to burn exactly 250 pounds. So 250 pounds is the goal, right? We could have changed it to 10, we could have done it to blah, blah, blah. But basically, what we're doing is we're finding the 2 points which allow the situation to happen. Okay, so if I burn 4 calories per minute bowling and I burn 5 calories per minute walking, x is the number of minutes I bowled and y is the number of minutes I walked, and that's going to equal 250. All right, now what I really need to do is I need to graph this to show you guys that it works, but I can do that. I can do it. All right. So so if you're using the slope intercepts to graph, be sure that the equation is in ax plus by equals c. And so basically, if I graph this, I need to do it twice. And let's see here. Let me go ahead and put a thing in here real quick. There we go. Done. Okay, so there we go. So let's go ahead and graph this real quick. Now, as you'll notice, I'm not really giving much priority to the second, third, fourth quadrant because all of these numbers are positive. You're not going to exercise negative minutes, right? So if x is bowling, then my x-axis is bowling. If walking is y, then my y-axis is walking. And I'm going to go ahead and let's go do the x-intercept first. So, and again, I wasn't planning to do this, so this might go on a little longer. So if you already get the graphing part, you can skip this part. But if you're still struggling with the graphing, this might help you. So for finding the x-intercept, y has to be 0. So 4x plus 5 times 0 equals 250. That's 0, so 4x equals 250. So I'm going to divide. Let me get my calculator real quick. So that'll be faster than me doing this mentally. It's 250 divided by 4 is 62.5. So x equals 62.5. So you have to bowl for just over an hour for this to really work out for you. And then, so that's the point. 62.50, and then if I'm going to, this bowling is a little big, I need the extra space. I'm going to erase it real quick and make it a little smaller. Bowling. There we go. And let's do the next one. So the next one would be when x is 0, so 40 plus 5y equals 250. That's 5y equals 250 divided by 5 divided by 5. 250 divided by 5 is 50. So y equals 50. So you would have to walk for just under an hour for 50 minutes along with bowling just over an hour to burn 250 calories. So that's a long time. But you know what? Hey, it's okay. The swimming was much better, which is why I swim. All right, so let's go ahead and graph the intercept for the the x-intercept. So if I'm going to do this by tens, so it's 20, 30, 40, 50, 60, 70. This is going to be as close to an estimate as I can. There we go. So that's the point 62 or 62.50, and my other one, which I did in orange, so I'll keep it in orange, 10, 20, 30, 40, 50, 60. This was at 50 minutes, so it's right spot on. So here we go. So that's my line. So basically any point on this line would still allow me to burn 250 calories, either bowling or walking, but the difference would be there. So here, I could walk 0 minutes, but bowl for 62.5 minutes, and I would burn 250 calories. Or I could walk 50 minutes and not bowl a single thing and burn 250 calories. Or I could, kind of get, my graph's not perfect, but that kind of looks like it's a point, which means I could bowl for 30 minutes and I could walk for 30 minutes and I'd still burn 250 calories. And again, you could check how accurate my my graph is by plugging 30, 30 in for x and y and seeing if you still get 250. That would really tell you if my graph was on or off right there, just by, well, the point is supposedly on my graph, but it doesn't really work with the equation, and that's something you can check. All right, I've already gone further than I thought I was going to go, so make sure you guys understand that when x is 0, y is basically playing all the part. Everything is on the y-axis. But if y is 0, then it's basically everything on the x-axis. But if you're on the line still where, x is 0 or y is 0 and you got the intercepts, that it still makes the equation true because the line holds all of the points that make the equation true. All right, moving on. And moving on so that I stop, actually.